Hey everybody, welcome back. This is Dr. Kolodnicki, and today we're doing lesson 24, multiplying polynomials with grids. So we're going to build off what we did in our last class using grids to kind of organize our work when we're multiplying monomials and binomials. And this time we're going to be doing polynomials. So I'm going to start off by just writing our expressions just the same way we've been doing them, either with algebra tiles or in grids. We're going to go across with one expression and then down with the other expression. So I'm going to start, obviously this one has 3 terms, that's why I'm going to put it in this first box. But again, order does not matter. I'm going to also include the signs because that's super important, especially when we're multiplying because those signs may come into play. And here we go. So now that my setup is correct, what I'm doing now is a bunch, 6, different small multiplying problems. To help me out here, I'm going to add in any coefficients that I don't see and any exponents I don't see. Every variable has a coefficient, number in front. Not every variable has an exponent. So I'm going to put in a 1 here. I'm going to put in a 1 here. And again, we're doing 6 small multiplying problems. If you recall in our last one, what I mean by that is for this particular box, I'm multiplying the 2 boxes that intersect it. So I'm multiplying 3x squared times 2x to the first. And I'm not going to write this for each of them, but just to show you the first box what we're talking about. And now if you recall, when we multiply, we're multiplying our coefficients together. So again, if I had this on my paper, I'd be doing these on the side, 3 times 2, and I would get 6. And then I remember when I'm multiplying, I add coefficients of like bases. So 2 plus 1 would make 3. So this is going to be x to the 3rd power. Okay, I'm going to repeat that again. If you can do it on your own, I would pause the video right now and try to fill out the rest of this and then come back and see if you filled it out correctly. So I'm going to give you a second to pause the video if you need to. Okay, if you're back, that means you're ready to go over these if you tried them on your own. So again, I'm moving over to this box. It doesn't matter which box you do in which order. I'm just going to do this. This is 4 times 2. 4 times 2 in my calculator would make 8. So I'm going to put 8 here. And then I'm going to add my exponents, x and x. 1 plus 1 makes 2. So it's going to be x squared. Again, repeating the process, multiplying the numbers or the coefficients together and adding the exponents if I have them. 2 times 2 makes 4. No variable, so I just have x. So I'm just going to leave it as plain old ordinary x. Could write the 1 if I want to, I don't have to. Now I'm going to repeat again, 3x squared times 3, multiply the numbers together, 3 times 3. I'm going to get 9. Nothing to add with this 2 as an exponent, so I'm just going to leave it as x squared. Continuing on, 4 times 3, positive 4 times positive 3 makes positive 12. Ooh. And then I have x to the 1st power with nothing else being multiplied by it, so I'm going to leave it as x to the 1st power. Then my final problem right here, I have 3 times 2, which is just going to be positive 6. Oops, moved it around. And if you recall, when we talked about combining, we're going to have some like terms here. If you recall, it's always going to be the ones that kind of go across from each other. But you can always look for them on your own. So I have an x squared and an x squared. I have an x and an x. These are like terms. So what I can do is I can kind of combine them as I go rather than have to rewrite, 6 different terms out. So it's up to you. You can rewrite this whole thing out. And again, if I don't see a sign, I'm going to assume it's positive. That's a lot to write. And then I'm going to have to combine these like terms and combine these like terms. Or what I could have done is just started with 6x cubed and then just added these guys as I go. So let's see what 9 plus 8 is. I'm adding those guys, 17. So together I will have 17 x's, x squared, sorry. Ooh, this should be a 3. Almost made a silly mistake. And then I'm going to combine these two like terms, 12 and 4, and I'm going to get 16. So that will be 16, and then the like term will just be x, and then this last constant at the end plus 6. Again, I really like grids to kind of organize our work, to help us just keep everything organized and simplified. And I think in terms of being able to do this on a test, this I think is the easiest way to do it. But you do have to make sure you know how to set it up properly, and you know the rules for multiplying monomials. Alright, so the last problem for this lesson is just to kind of consider this problem. 5 plus x times 5 plus x times 5 plus x. What do you notice? What do you wonder? And then we're going to try it out together. I'm going to show you how crazy a problem can possibly be, but it's something that you should be able to do on your own. So let's see what you notice. Take a second, maybe jot some bullets down. Again, I'll be jotting some down in my copy of notes, but I want you to jot some down now. Let's see if you can figure it out. What's some things that you notice? What do you wonder about? How are we going to solve this problem? Maybe that would be a how do you wonder? What do you wonder? Alright, so I noticed that they're all alike, right? They're exactly the same. And I noticed that there's 3 of them. And since we've been doing this grid method, we really haven't done more than 2 binomials or polynomials multiplied at one time. So we're really going to only be able to do 2 at a time. Another way to write this, which is pretty cool, and you may want to jot this down as well, is with an exponent. When I'm multiplying something, by itself, it's the same thing as an exponent, so it's 5 plus x to the 3rd power. That's what I would write if I got this kind of problem. So now I'm going to use my grid method, but again, I can only do 2 at a time. So this is my first kind of grid, and then my other one on this side again is going to be x plus 5, 5 plus x, and now I'm going to make that grid kind of in the middle. You know what? I didn't like the way I did that. Let's change that up. Let's try that again. I'm just going to write 5 plus x, and then I'm going to write 5 plus x, and I'm going to make a grid here. That looks better. Again, my answers are going to go in those 4 boxes, which means I have to do 4 small multiplication problems. Again, if I need to, which I definitely do in this case, I don't have any coefficients, and I have no exponent. Same thing, no coefficient, it's a 1, and no exponent, now that's a 1, and now we're ready to multiply. 5 times 5 in my calculator, 1 times 5, nothing to add this 1 to, so it's just going to be x. 5 times 1, x, nothing to add it to. 1 times 1, I have like bases, so I'm going to add their exponents. 1 plus 1 makes 2. X squared. Okay, I'm going to use that trick that we talked about above. I'm going to add the like terms as I go. So right now I have 25, which does not have a like term. Positive 5 and positive 5 add together, combine to make 10x. And this 1x squared is all by itself. So far I've only multiplied 2 of these together, and I got this answer. Now I still have to multiply again a 3rd time. So if this was a problem on a Regents exam, I would expect you to do a little bit of work, and it's going to take you a little bit of time. It's not going to probably be a multiple choice question. I'm going to say it's probably going to be a part 2 question. I'm going to rewrite this in black up on top, and then I'm going to rewrite this next guy, the 5 plus x, underneath. And notice my grid got a lot bigger. I'm going to have 6 tiny little problems to do here. And I'm just going to start multiplying right away. 5 times 25 makes 125. Luckily I have my answer key in front of me so I don't have to do this on my calculator. 5 times 10 is 50 with just an x with a first power, so nothing's going to get added to that. 1 times 5 is 5. Again, no exponents to add, so I'm just going to leave it as x squared. Moving down here, I'm going to need to add a coefficient and an exponent just to help me out here. 25 times 1 is just 25. No exponents to add. 10 times 1, 10. I have a 1 and a 1, so that's going to be an exponent of 2. There's some. 1 times 1, x squared, and x to the first power. Combine those to be x to the third power. And again, talking about combining those like terms as I go, so I don't have to rewrite this. I'm going to start with 125. I'm going to combine 50 and 25 to make 75 x's. 5 and 10 combine together to make 15x squared. And then finally, 1x cubed. One final notice you might know is now that we started off with x's and we ended up with the highest power, and again, this isn't written in standard form. Let's just do that, might as well. Go over some good vocabulary while we're here. If I write this in standard form, that means I write it from the highest exponent to the lowest exponent in order. My leading coefficient is 1. My power is 3. My constant is 125, right? All good vocab words. But if you notice, my power of this final answer is 3, and I actually had 3 x's when I multiplied together. So my highest power is always going to be how many x's am I multiplying together. And above, you notice when we started with a 3x squared and multiplied by an x, our highest power was x cubed as well. So just take notice of that. Pause the video, copy this all down, and if you have any questions, feel free to ask them tomorrow. I'll see you soon.